Our topic today will be understanding the phases of the moon. I'm pretty sure that everyone knows we live on a planet. It has one satellite. We call it the moon. Its technical name is Luna. It's good to know if you're a poet. That's the main reason we have a moon, so that those guys have something that rhymes with spoon and all those little ballads. We also have a moon in order to ensure the stability of our own planet. So in fact, there is a valid school of argument that says that life would not exist here on Earth if not for the fact that we have a moon, and such an unusually large moon. So you should feel happy and grateful every time you look up there and you see the rabbit in the moon. How many people have ever seen a rabbit in the moon? In some cultures, there's not a man in the moon, there's a rabbit. What else have people seen when they look at the moon? Cheese! Excellent. A man in the moon? Yeah. Anyone else see pictures in the appearance, in the cratered surface of the moon? A horse? Good. I know this is hard to realize, but if you go back in time, back before you were born, before I was born, there was no television. So what did people do at night? All the lights went out and there was no artificial lighting. So they sat around looking at the moon thinking, wow, this is great. I can't wait for the reruns. Yeah. People were very sensitive to the appearance and the change in the appearance of the stars, the planets, and the moon in the past, because that was all that was on, and because it was essential for their own survival. Does anyone here work in agriculture? Anyone know what happens if you don't plant your crops in the spring? Nothing happens. You don't eat in winter is the end result. How obvious is it when spring has arrived? If your local weather is variable, you might not know when the optimum time to plant seed is. You might not know when the optimum time to do various things to the crops are, unless you know what day it is. So a calendar, some sort of yearly calendar, quickly became a very important tool for many cultures, long before the introduction of modern technology. And what would they use for clocks before clocks were invented? The stars, the planets, the moon, all these things were their natural timekeepers. So people were fascinated, for very good reasons, by the movements of the stars in the past. And because of this, they built their culture. They built legends about these objects in the sky. So the first thing we're going to do is each group is going to get together, and I want you to pick 2 or 3 stories about the moon. Draw from your own cultures. If you can't come up with that many, you can make up a new story and a new culture right now here in class. So let's start with that. So let's start by hearing a couple of ideas. Give me some short stories that shed insight on how the moon changes with time. That's good. So who caught the importance of what Garrett said there? He said, we don't know, we're just making stuff up. So we thought that if you lived in a jungle environment, you would see a monkey on the moon. If you lived in a forest environment, you would see a deer or a rabbit. How many people think that that's how other people, other cultures made up their stories about the moon? I'm on board, it makes sense. What does this tell us? It tells us that how cultures view the moon tells us something about those cultures, about their level of knowledge, about their ecology, about their superstitions, about how much they believed in the scientific method versus, say, superstition and ritual. Let's hear a story about the moon that sheds some insight into how it changes in the sky. So God created a cookie and placed it in the sky, and somebody started to eat it. Every time they took a bite out of it, the moon looked different to us here on Earth. Maybe those craters are chocolate chips. And then what happens? The God's children come along, and they start taking bites out of the cookie. Before you know it, there's only a little crescent piece left. And then, it's all gone. What happens next? God bakes another cookie and puts it in the sky. I like this myth. It's warm and comforting. It makes me feel good about myself. This is a good myth. So this is a story about what might be happening on the moon. Oh, how they were created. Well, that's good. That's important. That's a fundamental question many cultures ask. So the moon is traveling across the sky because it's pursued by a tiger and it's running away. That's good. But here's the question. We do know that the moon's appearance changes over time. So what do we actually know about that? What facts are we drawing on when we come up with these stories? What do we know about the change in the appearance of the moon? The pattern is repeatable. There's a pattern and it repeats. How long does it take to repeat? Oh, very good. 29.5 days. A month, roughly. So there's a pattern and it takes a month. And how does the moon change over the course of that month? It has 8 phases. I'm going to go out on a limb and say there's the cookie phase where it's all completely round and filled in. What happens over time? If you look at the full moon tonight, will it be bigger or smaller the next night? Smaller, right. There'll be a little less moon to go around. And Chris divided this cycle up into 8 phases. We got the full phase, which is exactly as advertised. Here, when the moon is more than half full, we call this gibbous. And that's kind of a weird word, so let's say it all together. Gibbous. Gibbous, excellent. Try and use that 3 times in your common conversation in the next 2 days, and it'll stick with you. If you see someone with a round face, tell them they look very gibbous today. We call this a quarter moon, either a first or a third quarter. That's a little deceptive because some people say, oh, it's half a circle. Why is it a quarter moon? That's what it is. This is a crescent. So if you've ever been to McDonald's, you know this one. And then here, this is what we call the new moon. So faint in the sky that people often miss it. But has anyone ever looked up in the sky and seen not the full, bright, gigantic, glowing full moon, but a very faint, full circle moon in the sky? So faint it's difficult to pull out. Has anyone ever seen that? What time of the day did you see it? Or night? Was it midnight? Early morning? Here's a big clue. You see this one during daylight hours. The full moon, the big bright moon, when do you see this one? Midnight. Excellent. So there's a pattern, a change in the appearance of the moon, and that correlates with the time of day at which the moon is in the sky. Can you always find the moon in the sky if you look hard enough? How many people think you can always find the moon if you look hard enough, if you go outside? At any time. Like if we go out now and I say we're not coming in until we find the moon, would I be lecturing anymore today? How many people think that there are times when the moon is not above the horizon? How many people haven't raised their hand yet? Ah, okay, fence sitters. Let's do a simple example in order to figure out this problem. So we're going to draw the Earth. That's a big round circle. Okay, we know it's a sphere, right? The moon is at some location. And for now, I'm not even going to worry about the pattern of the moon's orbit and where it might be. I'm just going to pick a random location and say the moon is right here. So if you are standing here on the Earth, where is the moon in the sky to you? It's overhead, right? You look up. Ah, the moon is falling. It's overhead. Now remember, the Earth is really big. If you're a really fast runner and you run a quarter of the way around and you stand here, and now you look towards the moon, you're sort of going to walk a line out like this. And because the moon is so far away, a line here, just make a line here that's 300,000 kilometers long, and you'll realize that these 2 lines blur into one. So if you're standing here, where does the moon appear to you? You're standing like this, right? So in the first case here, I look up and I see the moon. Second case here, this is the ground, and I am looking for the moon. So where is it to me? It's on the horizon. Excellent. Because I see it here. I realize, oh, wait, I dropped something. And I run all the way back, and then I keep running. I like to run. I get here. Where do I see the moon here? It's going to be on the horizon again. And then I go see my friend in Russia. And I say, it's a real romantic night. Let's go out and look at the moon. Where do I see the moon now? I can't see it because it's on the other side of the Earth. The moon is down there, all the way through on the backside. So at any point, the moon is in the sky, what fraction of the Earth can see it at any time? Basically 1/2. All the people in the front and then all the people on the back of the Earth. They can all see the moon. It might be overhead, or it might slowly drop onto the horizon. But can you all see that for 50% of the surface of the Earth, the moon will be present, and for 50% of the surface of the Earth, the moon will be on the other side of the Earth? Does that make sense? Good. This type of an argument, where we take a question and then we draw a diagram that really lays it out, this is very important in astronomy. This is how we solve most of the problems that we do. So often if I ask you a question like this and you don't know the answer, try and draw yourself a little figure. Ask yourself what matters in this problem, the Earth, the moon, me, and see if the answer will become more clear based on a figure. So we've determined that the moon changes appearance over the course of a month, that at any one time the moon will be visible to some people and not visible to other people. Let's see if we can build this model up more and determine how the moon's position in the sky changes its appearance. So I'm going to draw another very simple diagram. This diagram is going to have the moon and the sun. So we have the sun, and we know the sun shines light in all directions. I'm going to put the moon in some location, and at this point I don't even care where the Earth is. The moon, if you were standing on the moon, could you always see the sun? No. If you were standing here on the moon, where would the sun be? It'll be overhead. If you were standing here, where would the moon be? On the horizon, and here on the horizon. And then if you were here, of course, where would the moon be? The moon would... yeah, thank you. Good answer. Who said that? You're standing here, the moon would be below you, and where would the sun be? Hidden behind the moon. So what fraction of the moon can see the sun? Half. Another way to put that is that what fraction of the moon is lit? What fraction of the moon is in shadow? So here we have an idea that the moon is always half illuminated, shiny and bright, and half dark. I think there's a connection between the phase of the moon and what fraction of it is illuminated. So here's my first theory. Over time, that isn't a 50-50 relationship. Somehow, when you have a full moon, the entire moon is illuminated. And over time, less and less of it is illuminated. And then when you get to the new moon, the whole moon is dark. It's in shadow. That's why you can see it if you have really good eyes and you can pick it out against the sky. It's still there, but it's no longer reflecting light from the sun toward you. Each group, let's take 90 seconds and discuss my theory. My theory is the idea that the phase of the moon is determined by the fraction illuminated, the fraction that can see the sun. So this is my theory. My theory is that the appearance of the moon changes because over time, anywhere from none of the moon to all of the moon is illuminated by the sun. How many groups believe my theory? How many groups think my theory is about as good as the theory of a flat Earth? We've got some dissension in the ranks, and that's always good. Why do you guys not like my theory? Riva and her group say, hey, this bottom figure looks to me like the moon is always half bright, half lit up, and half dark. It doesn't matter where you put the moon. If you put the moon over here, half of it's shiny, it's reflecting the light from the sun, and half of it's dark because it's on the back. You put it here, same thing, shiny, dark. You put it here, half of it's dark and half of it's shiny. And she's saying, what in your model would explain why the moon might suddenly become all dark or all illuminated? Do they have a point? Is it a good one? Let's take another 90 seconds and figure out what's a better theory. I want a theory that explains why the apparent appearance of the moon changes with time, that accepts the fact that the moon is always half shiny and bright and half dark. Let's hear some theories. What is the key variable? If the key variable is not the fraction of the moon that can see the sun, what matters in this problem? What makes us see the moon change? I'm hearing the position of the moon around the Earth, the orbit. Let's try and refine that idea. Our position relative to the position of the moon. Good. I think you're all on the same track here. So let's see if we can draw a diagram that will illustrate this point. What's the source of light in the solar system? The sun. Good. So if we got behind on our payments and the sun was repossessed, would anything, don't laugh, this has happened, would anything in the solar system be glowing? When we look at the planets and we see them bright and shiny, or we see the moon, where is the light we see coming from? The sun. It's all reflected light from the sun. So the sun is the source of all the radiation, all the light that we see. Now let's add in the Earth and the moon. Now all these Lab A groups, they were getting at the idea that it's the position of you on Earth, and then it's the relative position of the moon in the sky and the sun that governs the appearance. So let's see if we can firm up that model. If this were true, we could take this and the idea that the moon is always shiny on the side that faces the sun and dark on the side that's hidden, put it in. So we draw a line to the sun to help us make a good diagram. Draw a line perpendicular to that. What's this side? It's all dark. This side? It's light and shiny because it's reflecting the light from the sun. Now we want to see what the person down here sees. So they look up, and they cannot see the entire moon. They only see the side facing them. So they look up, they draw a line on the moon perpendicular to the line between them and the moon. And what do they see? So this person looks up and sees the moon, and they see something that's very bright, and then there's a dark patch here that's hidden. It's still there. The moon is still a roughly spherical shape, but only part of the moon is shiny. What do we call that shape in the sky when the moon is more than half illuminated? Everybody. Gibbous! This is a gibbous moon. Now this diagram contains all you need to know in order to deduce the entire pattern of the phases of the moon. This is what we need to know. What fraction of the moon is illuminated by the sun? What fraction of that can we see from Earth? So if you understand that, you understand how the moon will look. That is the number one idea to take out of this class today. The number two idea is that by drawing a diagram like this, you can also predict where the moon is in the sky, whether it's directly overhead, whether it's on the horizon for you, or whether it's hidden behind the Earth. Now we're going to add one final idea to this, and this is the idea of a clock. So this is a 24-hour clock. We have the Earth, and what time is it when you're directly underneath the sun? It's noon. Good. This is a simple class, and what I mean by that is we don't worry about daylight savings times. We don't worry about being in the center or on the edge of a time zone. We say noon is when the sun is directly overhead. What time is it 12 hours later? Midnight. So if you are here, what time is it? It's 6 p.m. because the Earth rotates around So halfway between noon and midnight, that'll be 6 p.m. or dusk. And then over here, what time is it down here? 6 a.m., dawn. You can fill in all the other hours, noon, 1, 2, 3, 4, 5. It's a 24-hour clock. But as long as you know where the sun is, once you place yourself on the earth, you know what time it is. So those three ideas, we're going to put them together, and now we're going to predict the phase of the moon, the location of the moon, and where it appears to you at what time of the day or night. So to do this, we need some courageous volunteers. I need 2 volunteers from the studio audience. So I am the sun, Chris is the earth, and Courtney is the moon. So the sun goes on, and if you really wanted to make a better sun, you could use something like a camping lantern that's shown in all directions. But for our purposes, we're just going to use a flashlight. We have the earth, and we have the moon. And as you can see, the moon is shiny on one side, the side facing the sun, the side made of where you can really see the green cheese, and then it's dark on the back side. So at the moment, we've got our solar system frozen in an instant of time. So my first question to you is, if you're standing on the earth, right between the earth and the moon, it won't be a perfect lineup for the course of today. We're not going to worry about eclipses where objects step right in front of each other. If you're standing on the earth and you're looking straight up into my beam, what time of the day or night is it for you? It's noon. What fraction of the moon will be illuminated to you? None, because you're standing behind it. All you see is the dark side. That is the new moon phase. If you look very carefully in the sky when the moon is in the new phase, you can find it overhead around noon, and it's extremely faint and hard to see. Can you find it every day that way? Can you find it a few days every month? Absolutely. So what happens over the course of a month? What does Courtney need to do to simulate the movement of this system over the course of a month? She needs to walk around the earth. So this is a month. How many days was that? 29 and a half. Good. Everybody heard Chris. That's excellent. Let's put the moon where it would be overhead at 6 p.m. So what does Courtney need to do? She needs to rotate back, back, back. Yeah, excellent. Why is it 6 p.m.? Because the angle between the sun and the person, that's 90 degrees. So if at 6 p.m. the moon is directly overhead in the sky, what will it look like? It'll be a quarter moon. Excellent, Randy. It's the first quarter moon, in fact. So half of it will be illuminated, half of it will be shadowed. You will see that half circle shape. Everybody good? Let's see if we can delve a little deeper into this. So my first question to you is, at what time of the night or day would this moon appear on the horizon? Not directly overhead, but on the horizon. Midnight. Anything else? 12 noon. That's good also. What happens between noon and midnight on this day? If you're a person, visualize yourself standing on the earth. So at noon, you're standing looking directly into my beam. 6 p.m. we stop. Where's the moon in the sky? Directly overhead. Now take us around to midnight, Chris. He's walking around the earth, or the earth and his person. They're both rotating in place. Where is the moon now at midnight? It's on the horizon. What's it doing? It's setting, i.e. it's slowly being more and more hidden. What happens in the next 12 hours as Chris walks around through night and into early morning? Can you see the moon at all? Absolutely not. Where is it? It's on the other side of the earth. What fraction of it is illuminated by the sun? Half of it is illuminated, but the whole thing is hidden behind the earth. What phase does it have the entire time it's above the horizon on this day? It's always a quarter moon, right? Because the moon moves very slowly. It takes the moon a month to go around, and it took Chris 1 day. So the moon moves a little bit over the course of a night, but unless you're actually observing, you don't need to worry about that. It moves a little bit around, and the phase will change a tiny bit because of that. Courtney, can you take us to where the moon would be overhead at midnight? What fraction of the moon is illuminated by the sun? Half. What fraction of the illuminated surface can be seen if you're standing directly underneath the moon? You're going to see a full moon, so that was slightly ambiguous, so let's be clear. You'll see a full moon, and you will see all of the illuminated fraction of the moon. So you see the half that shines. If we go back to 6 p.m., but let's just go back in time 6 hours. So if Chris looks at his watch and it's 6 p.m., can he see the moon? Good. It's on the horizon. What phase does it have? It's a full moon. What time of the night or day will it set? 6 a.m. Because it will rise at 6 p.m. at dusk. It will be overhead at midnight. It will set at dawn. So those are the variables we want to be able to predict. We want to be able to predict the time that the moon rises, is overhead, and sets. We want to be able to predict the apparent phase of the moon. And we want to know when it would appear on the horizon. Did I already say that? Yes, I think I already said that. So we want to know its position and its appearance and the time of night or day. So now let's go slightly more in depth into something that Chris said. He said you can break up the moon's orbit into 8 positions and say that there are 8 phases, which is a good point. So we have the new phase. Let's take us back to the new moon phase. That's our first phase, the new moon. The moon is 50% illuminated, but we don't see any of it. So if you walk 1/8 of the way around the Earth, what fraction of the moon, of the illuminated surface, can be seen from Earth at this point? Very good, a crescent, a small little fraction. Can you all see how that would be a fraction, how that would look crescent-like? So we're at a crescent moon. That's our second phase. What's our next phase? Quarter. Take us to the first quarter. First quarter because it's the first quarter phase of the entire month. Next cycle, next phase, what's that? Gibbous, okay? Take us to gibbous. And now I want to add one more word. The moon at any time is either waxing or waning. Anything that's waxing, that's increasing. Anything waning, if you wane, that means you get tired, you fail, you slow down, you become diminished. If the moon is becoming more and more illuminated every night, it's waxing. If it's becoming less and less illuminated as viewed from Earth, the moon is waning. So half the time it waxes and the other half it wanes. What is it doing in this phase here? It's waxing. It's waxing the entire first part. It starts out as a new moon, and then it waxes for 2 weeks. So let's wax our way to the full moon. What happens one day after the full moon? It starts waning. And all we mean by that is that we don't see a full, perfect circle in the sky. We see less. Let's take us a few days forward, if you would, Courtney. So what phase is the moon in now? Waning gibbous. Very good. Put the two ideas together. It's waning, getting less and less illuminated, and it's still gibbous because it's more than half illuminated. What time of the night or day would it be directly overhead? 3 a.m. Very good. That's a good little mistake Courtney just made that helps us. Did everyone catch what her first answer was? She said the full moon, that's overhead at midnight, and we've moved off one phase, therefore that's 9 p.m. And then she caught herself and said, no, 3 a.m. So see, those would be the two answers. And at each of those positions, the moon would be gibbous. What phase would it be if it was directly overhead at 9 p.m.? Waxing gibbous. This, 3 hours after midnight, that is the waning gibbous phase. That's a very good mistake to make because it indicates you're starting to see how the 8 phases, positions around, are steps of 3 hours in time. If you can connect that 24-hour clock and those 8 phases and the position on the sky, horizon, halfway up, overhead, then you have this model in your head. Let's step forward to the third quarter. What fraction of the moon is illuminated by the sun? Half. Always half. That answer never changes. What fraction of the illuminated portion can Chris see if he's standing directly underneath it? He's going to see half of the illuminated or a quarter of the moon. So this is the third quarter phase of the moon. At what time of the night or day will it be directly overhead? 6 a.m. What time would you go out if you wanted to see it rise? Midnight. Good. What time would you go out if you wanted to see it set? Could you see it at all between noon and midnight? Between noon and midnight. Noon, 1 p.m., 3 p.m., 6 p.m. So in the second, why not? It's on the other side of the Earth, so it's completely hidden. Let's step forward one phase again. So what phase does the moon have? We're not at the new phase yet. We're still one phase back. Very good. I heard waning crescent, and that is the correct answer. So we've moved from third quarter one phase more. The moon is 50% illuminated, but the fraction that can be seen from Earth is only a thin crescent. What time of the night or day will that moon rise? 3 a.m. That's good. What time of the night or day will that moon set? 3 p.m. Okay, do you see a pattern there? How many hours a day is the moon visible in the sky? 12. So if you know when it rises, add 12 and you have the setting time. What time will it be directly overhead? 9 a.m. Good. Let's take a break. First, if we could thank our 2 bold volunteers. Thanks, guys. Really appreciate it. I have a theory, and that theory goes as follows. It says that when we take the midterm exam, Courtney and Chris are going to ace the problem on the phases of the moon. And the reason for that is pretty simple. They were up here, they were going through the model. They were fully engaged in the process. You might have noticed how every question I asked, they answered it. They might have been quiet a few times. They were answering every single question. How many people in the audience answered every question that I asked? Here's my point. Engagement equals knowledge. So let's break into groups. I'm afraid we don't have 16 sets of the total model here. But I would like each group to go through the argument. So the way I usually do this at home when I'm explaining it to people is I just use my fists. Now that you've seen the model, that shouldn't be so hard. Pick a piece for the sun, pick a piece for the earth, pick a piece for the moon, and I want you to walk through, do the same exercise that we did. And let's test everyone's knowledge and see if you can predict the rise time, the setting time, the time overhead, and the apparent phase of the moon at any time of the night or day. Let's go ahead and break into groups and do that. Ryan brought up an interesting point, which is, do the two crescent moons look alike? The waxing crescent and the waning crescent are slightly different, and here is the key difference. When you look up in the sky and you see a waxing crescent, you see, we're going to call it the right side of the moon illuminated, the side pointing towards the sun. 3/4 of a month later, when you see the waning moon, it's going to be the other portion of the arc. So to be clear, we've got the Earth here in the middle, we've got the sun over here, here's the moon in its cycle going around. So in this quarter here, we have the waxing crescent moon. The big moon, remember that half of it is illuminated, half of it is dark. We look at it from Earth, we see a portion illuminated, that's here. 3/4 of a cycle later, the moon is still a circle. Half of it is still dark, half of it is illuminated. From Earth, we look at that, but the portion that we see illuminated is now on the other side. So it's like looking at a circle, and on one time you see the right side bright, and on the other you see the left. Can everybody see that, how it's a mirror image? That's a nice point to keep track of. The same for the gibbous moon and for the first quarter and the third quarter. They're mirror images of each other. So the waning cycle and the waxing cycle mirror image, because the sun is always in the same place. So the portion that is illuminated is always facing the sun. Now I have 2 more questions to check everyone's knowledge. Let's go back to our waxing crescent moon. When does this moon rise in the sky, the waxing crescent? 9 a.m., right? 9 a.m. here. Over 6 hours, time passes. When is it directly overhead? 3 p.m. When does it set? 9 p.m. That's good. When it's rising here, in what direction is it rising? Which direction do you look on the horizon to find it? You look to the east. And the easiest way to figure that out is to ask yourself, if you get up and you see the sun rise, where does the sun rise? It rises in the east. What makes the sun and the moon appear to rise? The rotation of the Earth. So we're spinning around once a day, 24 hours. That's much faster than the monthly cycle of the moon or the yearly cycle of the sun. So we see everything rising in the east. The sun rises in the east, the moon rises in the east, the stars over the course of a night, they all rise in the east because we're spinning that way. We are driving that. Now if everything rises in the east, where does it set? The west. Good. All right, one final question. Do you ever see the moon in the north? Remember the pattern. If you have the sun, you have the earth, we have the moon. This is a month cycle, right? I'm going around in a circle. I'd have to go up here to be north. I'd have to go down here to be over the South Pole. Instead, the moon is in a stable orbit. It's always pretty much over the equator. Forms a circle around the equator of our planet. So unless you live at the equator, the moon will never be directly overhead for you. Once you rise up in the northern hemisphere, the moon always stays closer and closer to the horizon. In fact, if you live at the North or the South Pole, the moon stays on the horizon. It never rises directly overhead because the moon does not jump above the North Pole or below the South Pole. Special thanks to your group leaders today. I appreciate all your efforts.
People often ask how to distinguish between the waxing and waning crescent moons, between the first and third quarter moons, or between the waxing and waning gibbous moons. These partnered phases are mirror images of each other, reflected from left to right. There are 2 points to keep in mind. First, remember that the moon waxes as it grows from a new moon to a full moon and wanes for the following 2 weeks. This means that the waxing phases of the moon occur when the moon is overhead and visible between roughly noon and midnight, while the waning phases are visible late at night and early in the morning, from midnight to noon. So if you are looking at the moon in the sky, knowing what time it is will tell you whether it is in the waxing or waning phase. You can also keep observing for a few nights in a row. If the illuminated portion of the moon grows, then it's waxing. Second, recall that the moon makes a counterclockwise circle each month around the Earth when viewed from above the North Pole. It spends 2 weeks on one side of the Earth and then circles around to spend 2 weeks on the other side. If you are observing the moon from the northern hemisphere, then you stand facing south to find it in the sky. If it is waxing, then it will be illuminated on its right side, the side facing west towards the sun. If it is waning, however, then it will be illuminated on its left side, facing east instead. So if the moon rises and leads with its illuminated side, it is waxing. But if it rises and the portion cast in shadow rises first, it is waning. I want to make sure that you use the resources linked to from this web page because they contain a great deal of information about the causes of the phases of the moon. The most important resource listed here is the tutorial, the first link. This is a 14-page web tutorial that will walk you through visualizing the movements of the Sun, Earth, and Moon over the course of the lunar month. It contains several animations that show what the lunar phase and position of the Moon look like, both from above the North Pole and from our position here on Earth. Those of you who have been using these notes, who were not able to work with an instructor face-to-face in the classroom, should find this tutorial to be very useful because it allows you to duplicate some of the exercises that we do in person. The best ways to become comfortable with understanding the lunar phases are to practice visualizing the positions of the Sun, Earth, and Moon, and to connect the appearance of the actual Moon in the sky with your model. So make sure to get outside and look for the Moon every day and every night as well. You can also practice with your lunar phase wheel, constructed from 3 pieces of paper and showing the lunar phase and time of day throughout the month. Put your lunar phase wheel together when you begin to study this topic, and you'll find that it will help you to visualize the key elements. The second link leads to a demonstration created by the National Optical Astronomy Observatory. It includes video clips showing how to simulate the phase of the Moon by shining a bright light on a spherical object, like an orange or a tennis ball. The third link shows you how to place a 24-hour clock on top of the Earth and how to relate the time of day to your position on the Earth relative to the Sun. It also reminds you of the connection between the names of the 8 primary phases of the Moon and their appearances. The fourth link leads to another animation of the Sun, Earth, and Moon. You can experiment with changing the speed of the animation to see a whole lunar month play out in 5 minutes and place yourself either on the surface of the Earth or high above the North Pole.